Okay, whew, we're halfway there. Let's use all that stuff now to get our z-scores and then finally to get our linear correlation coefficient. Let's see, for the z-scores I'm going to need the variables minus their means. So let's just fill that in from the table above. For x minus x bar we had -2, 0, and 2. And let's fill in the means from the table above too. We had a 3 and a 6.6 for our means. Let's fill in the y minus y bars too. We had -2.5, 1, and 1.5. I didn't really leave room to show all the z computations in the table, so I'm just going to do a couple of them down below here for you. So to get the z-score for x equals 1, we're going to take 1 minus x bar, which is 3, and divide by s sub x, which is 2. So that's -2 over 2, which is -1. So I'll put a -1 in there. If we go over to the y's, the z-score for y equals 4.1 will be 4.1 minus the mean for y, which was 6.6, and then we divide by the standard deviation for y, which was 2.179, and we get approximately -1.147. So I'll put that into my z sub y column. And filling in the rest, my next z sub x's are 0 and 1. And my next z sub y's turn out to be 0.459 and 0.688. Now to fill in the last column, we take each of our z sub y's and multiply by each of our z sub x's. So in the first column, in the first row, I'm going to have -1 times -1.147. Okay, that's that times that, which gives me a positive 1.147. Then for the next row, I'm going to have a 0 times a 0.459. That's going to be a 0. And for the last row, we'll have 1 times 0.688, which will be 0.688. Then we add up the stuff in this last column. And if you do that on a calculator, you will get 1.835. We're finally ready to use our actual R formula, which says in the numerator to have the sum of those zx times zy's, and we just said that sum was 1.835. In the denominator, we have the sample size 3 minus 1. So if you do 1.835 divided by 2, you'll get 0.918, rounded off to 3 decimal places. What does that tell us? Well, it turns out, and we're going to write this down on the next page, so you don't need to write it down right here, but it turns out that if your R value is close to 1, That means your dots line up pretty well in a straight line. So something like that. You can see that these three dots, they're not just all over the place, they are kind of in a line.